Hi again. Now I'm going to talk in greater detail about differences between using Ansible for Linux machines and conventional network devices, and I will also give you a practice example of what is possible with Linux but is not with Cisco IOS. Here are our lab steps, let's go through them. At first we will run our playbook only with fact gathering functionality against Linux. Next we will try to do the same with our IOS router. Then we will disable fact gathering and run it one more time. Then we will add one more task with shell module and again run it first against Linux, second against Cisco IOS router. Then we will change connection type to local and again try to execute it against Cisco IOS router. Why we need all these tweaks, changing connection type to local, disabling fact gathering, we will find out in this video. I've already created all required files, so let's examine them. Ansible.cfg is in fact the same, so I've just copied it from our previous lab. But inventory file and playbook are different. Let's start with inventory file. Here we see two groups of hosts. First I called Linux and it contains our Fedora box with its credentials. Here we can see its IP and its password. Second group is called Cisco and it contains our IOS router with its credentials. We can see a difference here. We have Ansible user-defined for Cisco, but we don't have the same for our Linux machine. Ansible default behavior is to use username which executes playbook as SSH username. So for example, here I'm logged in as root, and if I execute Ansible playbook, it will use this username root as a username for SSH. So if I can SSH into my Linux box with username equals root and password equals Cisco, that's fine. We don't have to specify it one more time. So we are good with our default Ansible behavior. Now let's examine our playbook. At first, pay attention to hash sign. It basically means that following string will not be executed. So if we have a hash sign here, it means that gather facts equals false. Ansible will just skip this line. Same for connection equals local and same for all these lines. So if we exclude all commented out lines, we see that our playbook is very minimalistic. It is pointing to our Linux machine and outputs Ansible facts variable content using debug module. So here we define again our Linux machine. Actually here we define hosts which Ansible will use in this play. Remember that it is play specific configuration. Here we see our tasks. We have just a single task. It is using debug module and outputs Ansible underscore facts. Now, when we are familiar with the code, let's try to execute it. Here we see pretty long lists with some variables and the content. And it is actually our fact gathering functionality. And pay attention here. Inside our playbook, we have only a single task, which is called first task. But when we run our playbook, we can see here two tasks. At first we see task called gathering facts, and next we see actually our task called first task, which outputs Ansible underscore facts variable contents. It happens because we didn't disable fact gathering functionality, and by default Ansible will try to gather facts. So in our case, Ansible did it. It gathered facts. So it was able then to output Ansible underscore facts variable contents. So basically, our playbook, Ansible executed our playbook, SSH into our Linux machine, gathered facts, and then output its contents. So here we see a lot of information. For example, architecture of our Linux machine, BIOS date, BIOS version, and many more information. For example, information about our distribution, which is Fedora. Information about our network interfaces, and many more. Again, you can use this information later in your playbook. So for example, you can get facts from your machine, and if there is some useful information for you, you can access it using Ansible underscore facts variable. Now let's try to run the same playbook against our Cisco IOS router. To do it, we just need to change our scope. So here we replace Linux with Cisco. Again, Linux and Cisco are group names. So if we run this playbook and this play, first play, against hosts called Cisco, Ansible will actually run it against this IP with these credentials. Since this machine is member of Cisco group. But in this case, we don't see any useful output. We don't see similar information. And here is our actual difference between Cisco IOS box and a regular Linux machine. We can't execute gathering facts task. You can see errors here, SFTP transfer mechanism failed, SCP transfer mechanism failed. It actually means that Ansible tried to connect to our iOS box and upload some Python scripts to gather facts. Actually, Ansible counts it as unreachable task, but in our case it is very similar to failure. We can assume that since here we have task called first task, and Ansible didn't even try to execute this task. So let's quickly return here. We've completed this step, and now let's try to disable fact gathering. To do so, we just need to uncomment our line. that line. GasEffects equals false. So right now, when we don't have a hash sign at this line, Ansible will not try to GasEffects. I ran this playbook one more time. This time it finished successfully, but our Ansible facts variable is just empty, since we didn't try to gather any facts. And we have this variable defined, but we just don't have any contents, any information inside it. So now we can try to add one more task, shell module, and see what happens next. So let's jump back to our Ansible control machine and edit our playbook one more time. I am deleting hash signs and actually uncommenting these lines. Here we use shell module, and shell module actually executes any command we want. And in our case, we use a command called uptime. And next task, and next we will register results of that command to a variable called uptime. And in our next task, we will show contents of that variable, again using debug module. And one more thing, I need to change again our scope from Cisco to Linux, since at first we will try to run it against our Fedora machine. And here we can see our results. So we see our first task, which again tries to output Ansible underscore facts variable contents, which again are empty, since we don't have fact gathering. It is false. Now we try to execute a command. In our case, command equals uptime. And here we try to show this variable, show this variable contents, since we registered in previous task results of our uptime command. So basically, Ansible executed uptime command, registered results of that command to uptime variable, and in next task, Ansible will output contents of that variable. And here we can see that info. We see command, which is uptime, a lot of different information, but right now we just need command, again, which is uptime, and standard out, and standard out lines. So this is actual output from that command. We can quickly try to do the same from SSH ourselves. So if we execute uptime command manually, we see a very similar result. Actually, only time differs. Let's go back and let's try to execute this playbook against Cisco router. And again we have the same errors about SFTP transfer and SCP transfer. And again, Ansible just can't upload Python scripts to our Cisco IOS box, and obviously it can't execute them, and at the end Ansible can't execute shell command called uptime. So basically it just doesn't work. Finally, we can try to change our connection type, since in our previous lab, when we used iOS command module and iOS config module, we used these modules with connection type equals local. Let's try to do the same with our uptime and shell module. And now it looks like everything is good. We have some output and we have some useful information. But actually, what happened? Ansible executed this task against our Ansible control machine. So connection type equals local means in most cases that module will be executed against Ansible control machine itself. So this result from std out lines, standard out. It is not result from our Cisco IOS box. It is result from uptime command from our Ansible control machine. So from this machine. We can see that it is very different from our uptime from our Fedora machine. So it is definitely, it isn't definitely our Fedora machine, but it is our Ansible control machine. To prove it even more, I can change uptime command to something Cisco-like. For example, show clock. And if we try to run this playbook again, we see that command show clock not found. If we try to do it manually, we see the same. Command not found. It proves that that Ansible, during execution of our playbook, tried to execute this task against Ansible control machine. So now let me give a quick summary. At first, we can conclude that in most cases we can't use the same modules for Linux and Cisco IOS devices. Some modules are of course universal, for example, debug module. Secondly, if our network device supports only SSH and some proprietary CLI syntax, we have to use specific modules. In case of Cisco IOS, we can use iOS command, iOS config, and some other iOS related modules. For the full list, please refer to Ansible documentation. Also, I want to mention raw module, which allows you to execute dirty SSH commands. If Ansible doesn't have specific module like iOS command, you can try to use raw. But remember that it is a very simple module and it is not idempotent. Idempotence is a safety mechanism which allows you to execute your playbook many times and always with the same result. For now, that's all. Please rate this video and subscribe to my channel. We'll see you soon.